week, as well as our speaker today. All right, let's get started. I would like to welcome you to the Center for Philosophy of Science with its online lectures this semester. Before introducing our speaker today, let me remind you of the events that are going to happen at the center in the coming days. On Friday, there is no lunchtime talk, but we have the last lecture of the annual lecture series, which is going to be given by Michela Massimi from the University of Edinburgh, and she's the winner of the she's the winner of the Adolf Grünbaum 2021 Memorial Lecture Prize. We would like to remind you that the lecture will not be taking place at 3:30 p.m. as is usual for the annual lecture series lectures, but at 11 because Michela is joining us from the UK. So again, 11 a.m. on Friday, this Friday, Michela Massimi will be talking about natural kinds on Eurosport. And on Tuesday next week, Max Schneider, who is a postdoc at the center this year, will be talking about empty space and the positive cosmological constant. If you're interested in any of these two talks, please join us on Zoom. You can go to the center's website, find the calendar and register for any of these two talks. On Friday at 11 for the last annual lecture series talk, and on Tuesday at noon for the next lunchtime talk. Today, it's my great pleasure to introduce Anna Rubin, who is an assistant professor of philosophy at Notre Dame in University of Notre Dame in the Department of Philosophy. She's also a fellow of the Rayleigh Center. Anna works mostly in the philosophy of biology and game and decision theory, with a strong focus also on social epistemology. She has published widely the philosophy of biology, often on topics related to kin selection and related issues. But she's also published quite a lot on issues related to social epistemology, often using game theoretical and decision theoretic tools to model questions in social epistemology. And indeed, today, that's the type of lecture she will be giving us, and her talk is entitled Structural Causes of Citation Gaps. And as the floor is yours.
I will start by sharing my screen. Oops, I clicked on the wrong button. Okay, so you should be able to see my slides now. Okay, great. So thanks, Edward, for that introduction, and thanks for having me come give a talk today. It's been great being part of the Center for Philosophy of Science this semester. So I wanted to talk about a project I've been working on recently, which is looking at what are called citation gaps and how they could arise in part due to what I'm calling structural causes. So these phrases might be totally unfamiliar to people. So just to explain what they mean before we get started, a citation gap refers to an observed phenomenon where women and minority groups are less likely to be cited in certain fields. And by structural cause, I just mean that the way academic communities are structured in terms of who's connected to who influences how likely it is that people have heard of certain papers, and therefore how likely it is that they'll cite papers from members of different social identity groups. So this is sort of a work in progress. I did some work on the project, and then I set it aside for a couple of years, and then I returned to it again fairly recently. So I'm looking forward to hearing what you all think. So here's the plan for the talk. Citation gaps have been the subject of a number of studies. So I'll start by reviewing some of these results. There are a lot of reasons people throw out for why this phenomenon exists, but generally the empirical work on citation patterns doesn't test the causes of citation gaps, but rather just determines whether or not a gap exists. So I'll present some mathematical models that I'll argue point to one possible cause of citation gaps in terms of the structure of the community. I'll explain how people generally capture the structure of academic or research communities in models, and then I'll present my own models which show that certain structures can be expected to give rise to citation gaps. Well, I think this investigation of citation gaps is important in itself because it's an important factor in discussions of gender representation and things like leaky pipelines and so on. I think what I'll be talking about today also illuminates some general lessons for research in what's called the science of science, which uses scientific methods to study science itself. In particular, I think there's implications for a lot of work in the science of science that aims to provide a picture of how to achieve well-functioning science, which often doesn't take into account the empirical work in other areas of science regarding marginalization and underrepresentation according to social identity. So I'll argue that this picture of how to achieve well-functioning science can change significantly once we take into account how social identity affects a researcher's place in a research community and the uptake of their ideas. So let's start with a quick overview of the empirical evidence on citation gaps. In many disciplines, gender citation gaps have been found where male scholars have higher citation levels than female scholars, including fields like economics, ecology, political science, library and information sciences, and so on. Some of these studies also find that women are less likely to be cited in subdisciplines which are more male-dominated. So plausibly, representation matters, and subfields with greater gender balance tend to have smaller citation gaps. While there are far fewer studies regarding citation rates according to race or ethnicity, citation gaps have been found, for instance, in law and social psychology. There are also fields where studies found no gender citation gaps, such as public administration, sociology, international relations, and so on. And a couple studies have found that women receive more citations in biochemistry and construction studies. I'm not aware of any studies published showing no citation gaps for race, which of course doesn't mean that there are no fields like that. It's just much less well studied. So in addition to these studies that focus on individual fields and are often focused on particular countries, there have been a couple of studies which look at gender citation gap, which they find that gender citation gaps exist when we look across many different disciplines and many different countries. In addition to looking at overall citation rates, which is what these studies I've been talking about do, one more specific empirical result that will be important for understanding my models of structural causes is what I'm going to call citation ratio gaps, for lack of a better name. So in this recent Dion et al. Article, they say that overall citation counts, quote, miss the sociological aspects of how scholars recognize the work of their peers, which is why at least some of the studies on citation gaps also look to see how often men are citing men versus women compared to how often women are citing men versus women. Basically, they look at a bunch of papers and see whether the gender of the authors of each paper predicts the ratio of male to female authors in the references section, or the percent of male authors in the references, or something along those lines. So we'll come back to these ratio gaps later. First, you might ask, what explains the existence of these citation gaps? Some proposed explanations of citation gaps include implicit bias and explicit sexism and bias, which I think the emphasis tending to be a little bit more on implicit bias as a possible cause. And there's some studies showing that bias could be at work, that people's evaluation of a paper can depend on the social identity of the author, and so may be a potential cause of citation gaps. There's also what's called the productivity gap, where men are found to publish more papers, and this can combine with the fact that men have been found to self-cite at a greater rate. There's also the observation that women's research careers tend to be shorter than men's. For whatever reason, there's a dropout gap or leaky pipeline where women leave positions at a greater rate. So all of these are probably relevant factors, but the possible explanation I'll focus on today is the structure of the community. As I said, I'll argue that the structure of the community in terms of who's connected to who and how information spreads through the network might mean that people are less aware of work by minorities and underrepresented groups. This sort of thing has been suggested before as a possible explanation of gender citation gaps, but usually it's addressed in a sort of informal way by saying maybe women are less well networked or something like that. So I'll give some more substance to this argument, showing exactly how network structure can affect citation rates in different social identity groups. Of course, there's many different potential factors interacting, and so when we look at these studies on citation gaps, we shouldn't expect the correlation between representation and whether or not there's a gap to be perfect, or even to find citation gaps in every field. It would be good to know something more about the causes of these gaps, but most of the work I've been talking about is limited to statistical analysis of citation patterns. And it's very difficult in general to test the potential causes of something like citation gaps. There's just too many factors at play in any given community. So to explore causal pathways that we can't get access to in the real world, I'll use mathematical models. These models can abstract away from the messy details of interactions in real academic communities and investigate a particular causal relationship of interest, like the relationship between the structure of the community and the size of citation gaps. But one more thing before I get into the models, let me just say something about how people often react to studies showing that there are citation gaps. So this seems to be a very common reaction people have to being told about citation gaps. They say, I cite whatever paper is best or most relevant, I don't look at the demographics. On the one hand, this sort of merit defense is likely true of many people who are well-intentioned in their citation practices, and asking people to think about citing members of marginalized groups can seem burdensome or unfair. On the other hand, this sort of response misses the mark a bit. There's an observed phenomenon that takes place whether or not any individual is biased. There being this effect is consistent with many individuals being unbiased. And if citation gaps are due, at least in part, to structural causes, this sort of response doubly misses the mark. It could be that everyone is using a totally reasonable strategy and citing the best, most relevant papers they're aware of without any bias, and yet this leads to inequities. This is because they're citing the best, most relevant papers of the papers they know about. Yet, due to the way information spreads through their academic network, they don't know about relevant papers from minority group members. And in fact, not looking at demographics is part of the problem. Okay, so I'm going to look at the possible ways the structure of the academic community can affect citation rates of different social identity groups. First, I'll say a bit about how academic communities are structured and how we can mathematically capture features of that structure in a way that lets us say something about how it affects citation patterns. Then I'll use this mathematical representation of academic communities to show how we can get citation gaps in a community of people who don't pay attention to demographics when deciding who to cite, and consider how these structural causes interact with some other potential explanations of citation gaps. The structure of a community is usually captured by a network, which is a summary of who's connected to who. So in the networks we'll be talking about today, we have nodes, all these dots, which represent different academics, and then the edges or links between them we can think of as representing regular communication channels, like regular collaborations or people who read each other's papers and give comments, something along those lines. Within the network, there are people of different social identity types. And these different social identity types can make up larger or smaller proportions of the total community. That is, we can meaningfully talk about minorities and majorities within the population. The communities I'll be talking about today are simplified in that we'll only talk about two different social identity types. For instance, men and women, with women being underrepresented and thus a minority in a particular academic discipline. One important thing that influences the structure of these communities is homophily, or the tendency of people to interact within their own social identity group. There are a ton of different ways to talk about or measure the homophily of a community, but simply put, we can say that there's homophily in a community if a person has a higher probability of forming a link within their own social identity group than with someone outside their social identity group. And the greater the difference between these two linking probabilities, the greater the homophily of the community. So there's lots of evidence that networks describing both academic collaborations and personal friendships are homophilic, that people of the same social identity can cluster into subdisciplines within a larger discipline, and so on. And there's a lot of reasons why people may consciously or subconsciously link more often with people of their own social identity group rather than those outside it. So I took this network image from a paper I have with Kaylin O'Connor, where we argue that one reason for homophily might be that minority groups break ties with the majority due to unfair distribution of labor in collaborative projects. However, networks aren't only homophilic because people are breaking ties. Homophily can also result from people seeking out connections with others like them for various reasons, such as receiving support or relevant information about how to navigate the profession as a member of some social identity group. In any case, there's good reason to include homophily in the structure of the communities we're trying to represent. And one way that people capture this homophily is by using what are called multi-type random networks. The idea behind these networks is pretty simple. You take two nodes, two academics, and with some probability, there's a link formed between them. This probability can be different based on the types of the nodes. For instance, there can be a higher probability of forming a link if they're of the same social identity group, and a lower probability if they're two different social identity groups. So to form these networks, you specify these linking probabilities, and you go through each pair of nodes, forming these links probabilistically. So taking all this about how to represent the structure of academic communities, I'm going to present some models which can help us see how this structure affects citation patterns. I should mention that a lot of what I'll say won't be specific to gender, but will apply more broadly to any social identity category that people take to be relevant when forming ties with others, even though a lot of the empirical work on citation gaps is specifically about gender. And I'll kind of switch between talking about gender and talking about minority-majority groups, and talking about gender when I'm relying specifically on modeling assumptions motivated by empirical data related to gender. I should also mention that these models are in some ways extensions of previous work I've done with Mike Schneider on how underrepresented groups can be disadvantaged when there are priority disputes over scientific discoveries. So thanks to Mike and the many people who gave suggestions for extending those models in our paper. Okay, the basic idea behind the model is that we can have two very similar papers arguing for or making the same claim. We can say that they come out at exactly the same time in similar journals and so on. So basically, all else being equal, does the social identity of the author make one paper more likely to be cited than the other? And here we aren't considering biases as having an effect. So really the only way that social identity influences citation chances is by influencing the place the author occupies on the network. So in this model, we start with two people publishing papers on the same specific topic, making a particular claim. And we're interested in the case where these papers are from two different social identity groups to see whether, for example, a paper by a man would be cited more often than one by a woman. So each time the models run, there'd be one randomly chosen man and one randomly chosen woman to be an author of these two original papers. So then we have these two papers, which new papers coming out can cite. So the model looks at what happens when these new papers come out and counts how often paper 1 gets cited versus paper 2. So we draw 100 people at random with replacement from the network to publish a paper, and when they do, there's some chance they're going to cite paper 1 or paper 2 based on how likely it is that they'll know about the paper. Now, of course, these new papers coming out also have some chance of being cited, but we're not going to look at that. We're just tracking how many citations accumulate to these two original papers. Does author 1 get more citations or author 2? So as these new papers come out, how do the authors decide which of the two papers to cite? Well, if the new paper coming out is by one of the original two, by an author of one of the original two papers, they'll cite themselves. The assumption being that they'll know about a paper they themselves wrote. If the new paper is not by one of the original two authors, there's some chance they'll hear about each of the papers through their network. And this chance is determined by what's called the path length between the author of the new paper and the authors of the original papers. That is, how many links does it take to get from one person to the other? So with probability P, an academic would cite their neighbor. With probability P squared, they would cite their neighbor's neighbor, and so on, decreasing with the length of the shortest path between them. So I have this probability set at 0.3, so there's a 30% chance you will know about a paper by one of your regular collaborators or friends, and a 9% chance that you would cite a collaborator's collaborator, and so on. There's nothing special about these numbers. Similar results can be obtained with different probabilities. So there's some chance a person knows about each of these two papers, and the assumption is that if they know about the paper, they'll definitely cite it. It's also possible that they cite both papers if they know about both. So I wanted to see how both homophily and the representation in a field affected citation gaps. So remember, there's homophily in a community if a person has a higher probability of forming a link within their own social identity group than with someone outside that social identity group. And the greater the difference between these two linking probabilities, the greater the homophily in the community. So here I looked at a range of cases, starting where these two linking probabilities were equal, so there's no homophily. And then every time I increase the in-group linking probability, I decrease the out-group linking probability by the same amount. This creates a range of levels of homophily as the difference between the linking probabilities is increased by 0.02 every time. So in the graph of the result, I'll just show the in-group linking probabilities, but know that as these increase, homophily will increase as well. So here's what happens for different sizes of the majority population and different probabilities of linking with your own social identity group. And what we're tracking is the citation gap. So how many more citations does the majority group member get compared to the minority group? So when there's no homophily, there's no citation gap. Both groups are cited equally as often. But as we increase homophily, the relative sizes of the groups starts to matter more and more. And in the extreme case of very high homophily and only 10% of the field comprised of the minority group, the citation gap is roughly 34%. So the majority receives 34% more of the total citations than the minority. And this matches with evidence that women are less likely to be cited in subdisciplines which are more male-dominated. That is, fields with greater gender balance tend to have smaller citation gaps. But also remember that it's important to pay attention to the sociological aspects of how scholars recognize the work of their peers. So for instance, the finding that men are more likely to cite other men, where here men are the majority group in these simulations. So first, let's look at how often the men cite men compared to how often they cite women. I called this the ratio in the majority group. So basically just looking at new papers coming out by men, how many times do these cite men, the paper by a man, versus how many times do they cite the paper by a woman? As you can see, this isn't really affected by the proportion of the field that men make up, but it is affected by homophily. So the more likely it is that men are connected with other men, the more likely it is that they'll hear about a paper by a man versus hearing about a paper from a woman. Just to note, even when there isn't any homophily, the ratio is slightly above 1 because of self-citation. I counted a man citing themselves as an instance of a majority member citing a majority member. And remember, self-citation occurs with probability 1 because people presumably know about their own papers. Okay, so here's the corresponding graph for the minority group. That is how often women cite men versus how often they cite women. Just like men are more likely to cite men with greater homophily, women are less likely to cite men and more likely to cite women as homophily increases. So their citation ratio of men to women is lower and lower as we increase homophily. In this case, the ratio also decreases as the minority group gets smaller. This is just because self-citation becomes more important as there are smaller numbers in a group. So in the network I looked at, there's only 100 people. So for example, if the minority is 10% of the community, that's only 10 women. And any new paper coming out then has a 1 in 10 chance of being by the author of one of the original papers we're tracking. So this effect shouldn't be as important in a larger network. Okay, but these two effects together give rise to the overall citation gaps. So if men are more often citing men, then as we increase the proportion of men in the population, men will overall be cited more often than women. Now, one thing you might think would mitigate this effect, and that a lot of people brought up to Mike and me in response to our paper on priority disputes, is the importance of search engines like Google Scholar to finding papers to cite. So I'll introduce a second model to incorporate the effect of search engines. So the second model is exactly like the first, except that when people go looking for papers to cite, they have some chance of finding a paper by looking through their network and some chance they find a paper to cite via an internet search. So here I have this as a 30% chance to cite someone you hear about through your network versus a 70% chance to go looking online. So when you go looking online, the chance that you find a paper is influenced by how many citations it already has. In general, a paper with more citations shows up earlier on an earlier page in the search. And the earlier a paper appears in the search, the more likely it is that someone will see it and therefore cite it. So the possibility of internet searches dampens or closes a little bit the citation gaps, but not as much as you might expect. So for contrast here, this green line representing high homophily goes from 0 to about 0.24, whereas before it went from 0 to about 0.34. So it's not like 30% of the time the majority are cited more often due to network effects, whereas 70% of the time people are citing each social identity group with equal likelihood based on their internet searches. If that were the case, we'd expect a 70% reduction in the citation gap. So from 0.34 to about 0.1. So 70% of the excess majority citations gone. So one reason why the citation gaps don't close as much as we might expect is that the search algorithm unintentionally encodes the structural advantage of the majority group. Because the chance you find a paper is influenced by how many citations it already has, and men are receiving more citations because news of their paper spreads to more people in the network, the chance that you find a paper by a majority group member is greater than the chance you find a paper by a minority group member when you're doing your internet search. Okay, so I've got two more quick models. These next models will be alterations to model 2 to look at how structural causes can interact with other factors relevant to explaining citation gaps. So I'll look at particularly the productivity gap and bias. I'll go through these models somewhat more quickly. So first, we can take into account the fact that in some fields, men have been found to publish more often than women. This is the productivity gap. This, of course, varies from field to field, but I just looked at how the results were affected when men published 1.5 times as often as women. So for this case, the rest of the model is exactly the same as the previous model, with both looking through the network and the internet searches. And we're still tracking citations accumulating to one paper by a man and one paper by a woman. It's just that the potential papers coming out that could cite these two papers are more often authored by men. So when you include this, as you might expect, the citation gap increases. So even when there's no homophily, and when there are equal numbers of men and women, the citation gap is about 0.5. And again, as we increase homophily, the relative sizes of the two social identity groups makes more and more difference. So the citation gap here starts higher than in the previous two models, and then reaches levels somewhere between the first and second models for high homophily and smaller relative size of the minority. So the second alteration to model 2 is to include bias. So forget about the productivity gap, but now think about what might happen if when a majority member comes across a paper by a minority, there's some small chance they won't cite it because for whatever reason, it just strikes them as not worth citing. So here I have that as just a 5% chance. And again, as you might expect, when you include this, the citation gap increases compared to model 2. In fact, as the reason for my slightly odd figure placement becomes clear, when we compare the results of model 3 with those of model 4, we can see that just a small amount of bias can affect citation gaps as much as a fairly substantial difference in publication rates, especially when the minority is small and the network is homophilic. Although we can see that bias has less of an effect in what we might think of as the baseline cases, so where there's no homophily or where there's no majority, so where groups have equal representation. Of course, in real academic communities, these effects that I've been talking about are not cleanly separable, which is, as I said, one of the reasons I think mathematical models are so useful. But it's important to remember that the factors I've discussed stand in complicated causal relationships with each other and to other factors that haven't been considered. So one thing you can't really explain using just structural causes is that even though citation gaps decrease as there's more women in a subfield, citation gaps still exist in some subfields which are female dominated. And in fact, in many fields, citation gaps have been increasing as representation of women increases. This could be due to bias or a publication gap, things I've discussed already, or any number of other factors at play. Like the fact that as more women enter fields, they aren't necessarily being given sought after research or tenure track positions, but instead often do more of the teaching or lab management labor. We might also consider prestige bias, so being considered one of the big names in your field or being employed at a prestigious institution can affect your citation chances and many other aspects of your career. And we might also think that access to good mentorship, which has been found to, in a lot of cases, to be a barrier for many social identity groups, is relevant and would help improve the quality of work as well as likelihood of publication and citation. You might also think that citations are playing a sort of signaling role to signal to the referees your competence in the field, and that referees are going to be looking for already well-cited people or papers, increasing citations to those who have already been well-cited and discouraging citation of others. And then, of course, there's the dropout gap, differences in funding, gatekeeping of particular subject areas, issues of who gets asked to speak at conferences, who publishes in higher prestige journals, and so on. So I should say, I thought about putting references for all these things on the slide, but it was already getting kind of overwhelming. So I just included some shout outs to Pitt affiliated people, since this is a Pitt lunchtime talk. In any case, I hope this makes it clear that while I do think what I've been calling structural causes are partially responsible for citation gaps, this doesn't mean that other factors aren't relevant. That said, structural causes are an important factor to consider, which may be hard to see from the data. Additionally, I think the existence of structural causes also points to other implications. So lastly, I'll talk about these implications. And in particular, I'll discuss two types of implications. So first, implications for how to address citation gaps and attempts to reduce them. And second, implications for proposals on how to achieve well-functioning science, which, as I mentioned at the start of the talk, often don't take into account issues of social identity. So I'll just talk about a few proposals to address citation gaps, though of course there are other proposals out there. So some argue that overcoming citation gaps requires recruitment of more female scholars and raising awareness about implicit biases that influence citations. Raising awareness of implicit bias could help, but if my argument is right, it won't get rid of citation gaps completely. Improving representation could also help with citation gaps, but as my results indicate, and as studies have found in more gender-balanced fields, the citation ratio gap will persist. So whether we should be satisfied with this possible situation of citation ratio gaps persisting as citation gaps disappear, I'm not so sure. And while equal representation is achievable for gender, it isn't for other social identity categories that may be relevant in the community. So while I think there are good reasons to do both these things, I'm not sure they'll be completely satisfactory. To fight citation gaps due to structural causes, I think that proposals which aim to promote visibility at the community level would work better, because the problem arises due to researchers not being aware of all the most relevant papers to cite. Of course, there are already some people and organizations which do this sort of thing. You might think of the diversity reading list, or maybe even MC Hammer tweeting profiles of people from underrepresented groups in STEM. So I guess what I'm doing here is in part adding justification and in part calling for more support of these sorts of things. And like I said, these structural causes have importance for other things as well. So in studying behaviors of complex systems, such as academic communities, it's important to be aware of potential feedback loops where initial inequalities may feed back into greater and greater asymmetries over time. The general importance of feedback loops in studying complex systems has been noted by many, for instance, by Sandy Mitchell. This is important also to keep in mind when you're using models to study the phenomenon of interest, as you might run into what's called the problem of back reaction. This is an issue particularly for simple models which hold fixed important factors in the background. These background factors may themselves change as a result of some proposed intervention, meaning we then must reanalyze the model in light of the new background. The damages of failing to account for back reaction have also famously been observed in the case of artificial intelligence algorithms approving credit or predicting recidivism, where it's been shown that by ignoring racial inequalities, these algorithms created a feedback loop where initial inequalities lead to future greater inequalities, not only entrenching, but amplifying injustices. Similarly, overlooking marginalization according to social identity may have major consequences when implementing models of how academic communities ought to function. While we should, in general, be sensitive to potential biases, in these cases, I think paying attention to structural causes takes on increased importance because of the way they can compound over time. So this here is a sort of general argument that I think is important in many areas. And now I'll provide an example of how this can occur, considering citation gaps and proposals to alter the peer review process. So there are many well-known problems with peer review, and suggestions for how to rectify these problems are everywhere. Many advocate abolishing pre-publication peer review and replacing it with a system where academics publish papers by posting them to an archive, where they're then reviewed post-publication. This is similar to what already happens in parts of math and physics. While the details of these proposals differ, under this sort of reform, feedback is no longer given by an assigned reviewer at a journal. It's performed by members of the community as they see fit post-publication. So I'll argue in the spirit of the general argument just provided that these reforms may create feedback loops which not only reinforce citation gaps, but amplify them. So I'm going to focus on the argument by Hazen and Bright. It's a recent paper by philosophers, and while I've been complaining that people providing proposals for well-functioning science often ignore issues of marginalization and underrepresentation, these authors actually do engage with these issues in a significant way. So to go through their basic argument, they say that abolishing pre-publication peer review would be a sort of Pareto improvement or weakly dominant strategy, not quite in the sense that game theorists usually use those words, but in the sense that for any standard of evaluating their proposal compared to the current system, abolishing pre-publication peer review is at least as good or better on that standard of evaluation. So this makes for a nice argument because then you don't have to worry about how to weigh one factor against another. So in their paper, they have a section of ways where they think abolishing pre-publication peer review would be beneficial, including faster sharing of results, more efficient time allocation for scientists, decrease in gender skew of publications, saving library resources from not paying so much for journal subscriptions, shifting to long-term measures of success, which are a better measure of importance of the work compared to journal impact factors, and a decreased reliance on a small number of gatekeepers. They also have a section of aspects of science for which evidence is that abolishing pre-publication peer review will basically make no difference. So this includes sorts of epistemic sorting, like saying which articles are of high quality, malpractice or fraud detection, herding behavior, and the effects of credit incentives. And finally, they have a section for potential difficulties for their proposal. One they dismiss, saying that peer review isn't as much of a guarantee of quality for outsiders as we think it is, and the other they take more seriously but think is highly speculative. So I'm not prepared to discuss this point by point or really give an opinion on whether we should actually give up pre-publication peer review. What I do want to do is comment on two issues I think are related to what I've said in this talk. So first, I think that the gender productivity gap should be removed from the benefits section. At best, it belongs in the makes no difference section. So here's just a quick argument for this. Many argue that this gender productivity gap emerges because whether or not there's actually bias in peer review, women certainly expect there to be. So women spend more time on each of their papers to ensure its quality is above whatever threshold for publication, meaning they write fewer papers. So Hazen and Bright reason that their proposed reform will ease the productivity gap, as women will be primarily concerned to publish when their paper meets their own rather than the community's standards. However, I don't think this would be the case, as women ought to anticipate a biased evaluation of their work separate from the publication process as well. There are various stages post-publication at which gender bias can occur, including in the accumulation of citations, and therefore in impact or visibility of work according to most measures, as well as in hiring and promotions, uptake of ideas, and so on. Women are, I think, at least as aware of these kind of things as they are of any potential bias in peer review, and so they'll still be concerned to meet the community's perceived to be biased standards, even if we abolish pre-publication peer review. Okay, so the second thing I want to talk about is this, what they call a runaway Matthew effect, which is a feedback loop whereby, in Hazen and Bright's words, quote, if there's an excess reward for some and an unfair passing over of others at the present stage of inquiry, this will ramify through to future rounds of inquiry, misallocating resources to people whose accomplishments do not fully justify their renown, end quote. So initial inequalities lead to greater inequalities over time. So Hazen and Bright say a lot about this runaway Matthew effect that I don't have time to get into, but ultimately say that, quote, our present thought is that this is a very speculative objection, and there's no empirical evidence to back up the claim that eliminating pre-publication peer review will have dire consequences in this regard, end quote. So I'll talk about this runaway Matthew effect in the context of members of different social identity groups, but I think it'll be easy to see how a similar argument applies more generally. While I agree with Hasten and Bright on the need for further empirical evidence and that this runaway effect might possibly be counteracted by sufficient additional reforms to protect those most likely to be impacted, I'll try to make a push for this being not so very speculative and an issue that deserves greater attention. And I'll do so by providing another model which demonstrates how a runaway Matthew effect can emerge in the sort of system that Hasten and Bright propose. Okay, so I'm going to leave a lot of the details out of this model. I'll just give you a basic idea of the mechanics. So scholars go about their research career both publishing their papers by posting them to some sort of archive and engaging with other papers that are posted. In order for a paper to receive post-publication peer review, it must first be seen by others. This can be achieved in a variety of ways, such as word of mouth, being promoted by those running the archive posting being retweeted, and so on. In general, the likelihood that someone will read and or share a paper by another researcher depends on many factors. For instance, whether they know that person personally, whether they're familiar with their work, whether they're employed by the same institution, and the reputation of that person. The likelihood of one researcher sharing another's work can be represented by what's called a weighted directed edge in a network. So directed edges point from one researcher to another, while the weight determines the chance that the first researcher will share or engage with a paper by the second researcher. So the first step of creating this model was to create these weighted directed networks. And I wanted these to be kind of as close as possible to the networks in the previous set of models. So here's what I did. Let's say we have a multi-type random graph like in the previous set of models. So in this model, there's 20 people in the network, but here's just a sort of simplified sketch of what this might look like. These edges are not directed, so I transformed the network so that each place there was an undirected edge, there's then two directed edges with weight 1. Then, since there's really some chance you'll engage with someone's paper, even if you're not connected to them, everywhere there was previously no link, I added two directed links with a small weight of 0.1. So this might seem like a kind of weird way to create networks, but like I said, I wanted these to be as close as possible to the networks in the previous set of models so that I could see what would happen if we were starting from that situation. As far as I can tell, there's not really a standard way to create homophilic weighted directed networks, and I don't really think the method of forming these networks is going to matter. But what's important about it being a weighted directed network in particular is that this formalism is well suited to identify the feedback loops I described before. In particular, by tracking how the weights change over time. So in this model, weights will change as papers are shared and engaged with. For instance, more people may become familiar with a person's work as it's shared more often, or someone can gain reputation from posting papers with high impact, ones that are cited or engaged with often. These sorts of factors will increase the weight of edges pointing towards that person, meaning that others are more likely to share and review their work in the future. So if this person in the top left here gains reputation, that means all the arrows pointing to that node are increased by a small amount. By tracking how these weights change over time, we can show how initial asymmetries due to social identity, that is, work from certain social identities being less likely to be shared or engaged with, can compound into greater and greater asymmetries over time. So to quantify and be able to measure these asymmetries due to social identity, I measured what I'm calling a centrality gap. Centrality is just a measure of how central a person is in the network, so how well connected they are, if you will. A centrality gap then just measures how much more well connected the majority group members are by looking at their average centrality compared to the average centrality of minority group members. The results I'm going to show, I used a very simple measure of centrality just based on the weights of incoming arrows. So then the centrality of a node I is found by just summing up the weight each other person in the network puts on I. So just sum up the weights of all those arrows pointing to that person, which remember measures how likely those people are to engage with that person's work. So I compared the centrality gap at the beginning of simulations to the centrality gap after 50 rounds of scientists publishing and engaging with each other's work. And here's the scatter plot for beginning versus ending centrality gap. So positive centrality gap means that majority group members are on average more central to the network, which remember means their work is more likely to be engaged with. Then a negative centrality gap corresponds to the situation where the minority group's work is more likely to be engaged with. So there's two important features I want to point out from this graph. First, and most importantly for the argument that I'm trying to make, is that the slope of the regression is greater than 1. This means that if you start with a positive number, you expect it to increase by the end. For example, 0.5 would increase to 0.6 with the slope here of about 1.2. If you feed it a negative number, minority group actually favored, you expect to get a more negative number by the end. So the initially favored minority group is more favored at the end. That is, starting with an advantage can create a feedback loop whereby you become more advantaged as time goes on. So the second thing to note here has to do with the size of the minority. These data points are actually color-coded according to majority size, but what's going on is kind of hard to see with them all in there, so let's put them on separate graphs. So if we separate out the data by majority size from 50%, where there's not really a majority, to where the minority group is very small, only 10% of the population, we can see how minority groups can be disadvantaged in terms of centrality, meaning that the feedback loops will in general serve to increase their disadvantage over time. So when both groups are evenly represented, this graph in pink here, the data points are pretty evenly spread out. That is, although there's differences in centrality between social identity groups, which can then feed back into greater differences over time, this isn't expected to disadvantage one group more than the other. To look at the case where the minority is small, 10% of the population, this plot in blue, more of the data points are clustered in the upper right portion, where the minority starts off disadvantaged and then ends up more disadvantaged in the end. So I'll return to this slide briefly, just to say that this model is obviously oversimplified. What I hope it does is serve to show the plausibility of a runaway Matthew effect for citation gaps, and a push to take these sort of feedback loops more seriously and to consider them when we develop our picture of well-functioning science. This is, of course, not to say that all members of academic communities must include considerations of social identity. Modelers always have to simplify, and we learn a lot from models which ignore important aspects of social identity. The point is that we ought to be careful in forming opinions on, arguing for, or enacting policies and reform without doing due diligence in investigating how they impact already marginalized groups. Thanks.
All right, thank you very much for this amazing lecture. Let me remind you how we're going to be proceeding. If you have a question for our speaker, please go to the bottom of your screen and click on the Q&A button. Then I will just write your name and I will promote you to the status of panelist, and you can directly ask a question to our speaker. All right, Kevin, I'm going to promote you. Great, Kevin, the floor is yours.
Hi, thanks. That was great and very convincing in all sorts of ways. I just wanted to ask a small, somewhat technical question about how you were setting up the maybe all the models, but at least the first models. So am I right that when you were saying you're encoding homophily as in the probability of a connection to someone in my group is greater than the probability of a connection to someone outside? Is that?
Yes.
So I was just wondering why. I was wondering if you could say more about that. So my intuition would have been like basically something that is more relativized to a base rate. So something like, okay, well, homophily should be something like, well, basically, if everyone has an equal chance to connect to everyone, that shouldn't count as homophily for any group, I guess I was thinking. But it seemed like if, it's 80%, 20% between group B and group A, then group B will be homophilous on that measure because they're more likely to connect to someone in their group. So yeah, I was just wondering about, presumably this won't make a difference, but I was curious about the choices.
No, so there's a lot of different ways to measure homophily. I think the one that you're referring to, which takes into account a base rate, often people use what's called inbreeding homophily. So it's the number of links within your group minus the proportion of the total group that your group makes up, divided by 1 minus the proportion of the group that your group makes up. And so it takes into account, like, okay, if I'm a minority group member, maybe 80% of my links are with those outside my group, but it's because there's just so many more of those people. So it's relativized to like sort of the base rate. But in general, if you have these two different linking probabilities, and if you have the in-group linking probability greater than the out-group linking probability, the resulting network is expected to be homophilous according to that measure, or many different measures of homophily as well. So the reason in my graphs that I use the in-group linking probability as sort of a proxy for homophily is because if I actually wanted to measure the inbreeding homophily, it'd be different for each size of the majority group. I'd have to like then recalculate it every time, and the graph would be kind of confusing.
I see. Good. That's the amplifying element. So the thought is this will give rise to that. Just this version, right? Is there? I mean, that seems totally right, and seems like totally fair type and measure of homophily. Is it right that on this? I guess when the base rates are really skewed, it seemed. Is it right that basically the probabilities of connecting to a group are going to be like hugely determined by which group I'm in, right? So if I'm in the 10% group, and we're in one of the models where like the in probability is.
Yeah, so maybe it'll help to just reiterate that these in-group linking probabilities are for like each 2 nodes. So it's not like, so if I'm in a minority and the in-group linking probability is much higher than the out-group linking probability, it still could be that most of my links are with out-group members because there's just so many of them.
Got it. Cool. I think that was not clicking. Yeah. All right. That makes good. Cool. I have another question. I'll jump in, but that's super clarifying. Thanks.
Thank you very much. Please join us for question. At this point, there is no other question. Kevin, if you want to follow up, you can. But in between, let me just ask, while people are joining us, ask a really sort of maybe not very well-formed question, but so a worry, I really love the paper, as you know, and but I have a worry when I was again listening to the talk about homophily. Homophily is a bit like similarity. Similarity, as you know, you're similar to everything in some respect, right? Now, homophily has a bit like that too, right? So why gender, why race, and not any other relevant dimensions that don't seem to matter, right? So there seems to be something built, do people from the northeast of the USA cite more people from the northeast of the USA than people from the southwest of the USA? Maybe yes, maybe no. Do people from Harvard cite more people from Harvard than people from Yale? Maybe yes, maybe no. And do you make any prediction about that, or is it just an independent factor that somehow has to be built in the model? And anyway, if what does it say if you need to somehow your model, if you need somehow to identify gender as a relevant dimension for homophilia?
Yeah, so I guess what I would say about why I'm focusing specifically on gender and race and ethnicity is because networks have been found to be homophilic according to gender and race. So the only situations where my model is going to be relevant are in cases where people actually do take that category of social identity to be relevant in some way when they're forming their connections. Now, of course, people do also, I mean, those aren't the only things that matter when people are forming connections. So you mentioned sort of geography or same institution. Those will certainly be cases also where you might expect to find more links than just sort of the base rate. I didn't talk about them because I don't really know about any evidence about how that impacts overall citation rates for these groups. But I certainly wouldn't want to rule that out or anything like that.
Thank you. Kevin Zollman, do you want to take it from there?
Yeah, sure. Thanks. Thanks, Hannah. It was a really great talk. And I sort of wanted, I'll just sort of ask the question, although I totally agree with both models. And in particular, I really like your objection to the Hazen and Bright argument. And in particular, I wanted to sort of, I guess a sort of follow-up question for Edouard's question, which is one other place where we know that networks are really homophilous is with respect to disciplinary and methodological boundaries, right? So I'm more likely to know of a philosophy paper or maybe an economics paper, less likely to know about a psychology paper, et cetera. I'm more likely to know about your paper, right? Because we're even in the same sub field. And so I'm wondering, if I were to take your model and claim that it says this, would you be comfortable, I guess, which is to say that your model is also an illustration of how post-publication peer review as a replacement for pre-publication peer review would tend to exacerbate any homophilous construction. So it would make disciplinarity worse, methodological isolation worse, it would make gender and racial gaps, insofar as racial gaps exist in citation, worse. Or do you think that there is something kind of important about gender homophily that's in those models that I'm missing out on?
Good question. I hadn't quite thought about that. So there's a lot of things that you just mentioned that I'm trying to consider all at once. So in terms of maybe like seeing papers from other disciplines, I'm not sure. I mean, so the papers that I think people tend to see, you know, from different disciplines tend to be those ones that are already highly impactful. And so Hazen and Bright allow a small role for journals in like publishing anthologies, and there still would be things like review papers, like overviewing a field. And since those are the places that people tend to get their information about other disciplines, I'm not sure whether that particularly would be impacted. I think that would also, I mean, it depends on the field, but like that would also apply for subdisciplines and things like that. Did that answer most of what I think you mentioned other things, but now I've
that's actually a really good point, which I hadn't thought of, which is that the role of things like review papers, systematic review papers, meta-analyses and things like that, that there aren't, at least or very rarely, systematic review papers of what the women in this field have done, whereas there are systematic review papers of like what this field has done. And so good, yeah, that's a really important disanalogy, which I hadn't thought of, and that's something which might contravene your model in one case but not in the other. Okay, no, good. Sorry, I'm thinking out loud, but yeah, that answers my question.
Okay.
Thanks for joining us, Kevin. David, floor is yours.
Hi, thanks so much for the talk. It was very exciting. So I know that you were focused on gender but also race, right? So I'm from Brazil. So I was particularly interested in your talk because, well, the first thing that I was considering here, wondering was about the language, right? So when you talk about race, in academic world, English is the main language, right? And also you propose some solutions like system, like the peer reviews method and etc. But and I know that you also mentioned the prestige bias, so where I'm heading in right now. So I'm wondering here how your modeling consider this kind of bias from race, considering that we, for example, we don't have access to, let's say, funds to do better research, instead of propose to change the system, the peer review method. Because particularly, I'm not interested. I know that this is an important issue, but I think that maybe the first thing is to consider to give other races and gender a better opportunities to develop their research, right? So even basic stuff like, for instance, if you consider the time that we spend to write a paper, right? Let's say that you have a good domain of of the English language, that you have a good idea to write about, but let's say that on average, someone from another state will spend like 1 month to write a paper, right? But someone who has the same domain of the language, who has a good idea to write about, but just because this person doesn't have a program like an EndNote to accelerate the process of references, he will spend or she will spend 2 or 3 months to write the same paper. So I'm just considering this option, this kind of scenarios as well. So it's not a question, actually, just a comment, and listen and see what you can make about this. So thanks so much.
Yeah, so that would be another thing. So like I said, my slide that said other factors was already getting kind of overwhelming, but that would definitely be another thing that would be appropriate to put on a slide like that, that this is another factor. So a lot of these studies on citation rates, I don't think they compare citation rates for people with different like nationalities or different like first languages spoken or something like that. That would be interesting if anyone knows of any studies like that. But I'm thinking this also has interesting relations to the Hazen and Bright paper, because one of the advantages they claim, which I think is totally right, is that switching to an archive system has greater accessibility. So with people who aren't at well-funded institutions, you can actually access the papers without like necessarily needing your library to pay for that. And so that would be great. This can also be accomplished by switching to a more open access type system.
Sure.
Yeah, but I also think that this might be relevant to the sort of runaway Matthew effect, where there's a similar sort of productivity gap going on there as you see with gender, maybe for different reasons. But given that and given initial inequalities, you might be concerned that there's a similar sort of runaway Matthew effect, even though there is this other benefit of greater accessibility. Is that?
Yeah. You're just giving me more information to think about, because just like, you're right. I think that you cover some of my questions. With that slide about some bias like prestige bias and funded bias and etc. I was just trying to give you more elements to think about, like like prestige bias. For example, if you think someone who works in a Latin America university and compared to someone who lives and who works in a North American university, even if it's not a good or great university in North America, it's still way ahead of someone who works in a Latin American university from the citation point of view. So yeah, I mean, thanks so much for your thoughts.
Thank you.
Thank you very much for joining us. We have time for a few more questions. No? Yes, actually. All right. Yeah, let me just move. All right. Colin, go for it.
Great, thank you. Yes, and thanks. That was very interesting. This is really just a quick follow-up from something that came up in the last question about the role of language. And I was just wondering if you're aware of work by Cassidy Sugimoto, where she's looked at Chinese social science papers and finds a citation advantage for papers in Chinese social science that have international reference lists. So if they're citing non-Chinese papers, controlling for all other factors, they get more citations. So I just wanted to point that out as something that might be relevant to your modeling.
Interesting. I've read a lot of her work, but I had not come across that particular paper.
Yeah, so I can, if you can't track it down, send me some email and I can point you to it.
Great. Thanks.
Great.
Thanks, Colin. Mike.
Hi, Hannah. Thank you for a fascinating paper. So this is probably not going to be too surprising, but I'd like to push you towards slightly more realistic models. And so I'm going to ask you questions about this data that you got. And I know you didn't collect it, but I'm perplexed by it. So papers get citations, not authors. And papers often these days tend to be multi-authored, even within the humanities. So how do you gender an article if it has a mix of gendered authors? And then what exactly are you assuming in your models? Are you modeling single author papers? And so therefore you can solve that gendering problem? And wouldn't it be more interesting to sort of look at, do women tend to cluster together as author groups, or do men tend to cluster together as author groups? How do you handle mixed author groups in terms of gender? And does it even make sense then to talk about these in-group, out-group dynamics? And isn't that the real social structure that we're kind of interested in science, as opposed to it at this higher disciplinary level? So why not this lab group level or co-author group level? So I just want more details.
Yeah. So let me, if I miss one of your questions, let me know. In my models, I'm assuming single authored papers for simplicity. So you're right about that. A lot of the data that's looking at citation gaps, there's a lot of different ways people measure citation gaps. You might not be surprised to find out. So oftentimes when people are incorporating multi-author papers, they will look at papers where women are in important authorship positions. So papers where women are either first or last author or single author. And they'll compare those papers, the likelihood that they get cited versus if men are then in the important authorship role. That's not always the case. There's different ways that people do it. In terms of the structure of the community and collaborative, like co-authoring, things like that, I have a couple papers on that. So one is with Kaylin O'Connor and another is with Mike Schneider and Kaylin O'Connor, looking at how you can get clustering into subdisciplines, basically, because you can get the emergence of sort of unequal divisions of labor, which then cause minorities to break ties with the majorities and sort of cluster together, mostly working with each other. And also, if you try to sort of decrease the collaborative homophily in various ways, it can actually backfire, because what you're doing is forcing people into collaborations where the minorities are getting sort of less out of the deal. And so you get sort of a temporary emergence of homophily, but then if your initiative ends, you get more homophily, and then like you've kind of screwed over the minority group in the meantime. So I will say these models are obviously simplified, and those factors are obviously very important, but it's hard to use one model to sort of get at all the things while still being understandable and clear.
All right. Mike, do you want to follow up, or good enough?
No, I'll talk to Hannah about lots of this stuff. I think it's fascinating. I really do think that as with most data modeling projects, the data collection part is probably one of the most important parts. And inconsistent and different ways of collecting this data, I'm sure would also be interesting to see how those filter through your models to produce interesting differences in those gender gaps.
Yeah.
All right. Any other question? We have a few minutes left. 1, 2, 3. So here we are. Thank you very much for this really great paper. And thank you all for joining us for this one of the last lunchtime talks of the semester. And we'll see you hopefully on Friday at 11, let me repeat, for the last talk of the annual lecture series. And on Tuesday next week for, I believe, the penultimate lunchtime talk. Thanks, Anna, for joining us, and thanks to all for coming to the Q&A. Bye, guys.